Hello, fifth graders. There's an old saying that we humans are often creatures of habit. One of the questions that I use over and over again, it's like an old friend. When I see a third or a fourth grader walking down the hall, and I know that that third or fourth grader wants to have a math question from me, wouldn't you? Weren't you in such a situation in the earlier grades where you received a math question from me? Now, I wouldn't give this question to a first or second grader, but I could give it to a third grader and certainly to a fourth grader. And through the years, I've had seen a lot of success that third or fourth graders are able to figure this out. Maybe I need to give a little bit of a prompt. The question is, what is 2/3 of 21? Why don't you think about that right now? If you need a little help, how about if I suggest this? What's 1/3 of 21? And if you know what 1/3 of 21 is, 2/3 of 21 is twice as big. So just multiply that result by 2. Let's look at it this way. Think of the 2/3 as 2 times 1/3. That's what 2/3 is. It's twice as big as 1/3. If we want to think of it this way, 2 times 1/3 is 1/3 plus 1/3, which is 2/3. You can multiply that 2 by the 1. Don't multiply the 2 by the 3 as well. If you do that, if you take the fraction 1/3 and multiply the top and bottom by 2, you don't get something twice as big. If you multiply the top and bottom of 1/3 by 2, you get 2/6, which is equal to 1/3. It's not twice as big. If you want the number that's twice as big as 1/3, you do 2 times 1, 2/3. Or the number that's 5 times bigger than 1/3 would be 5/3. Just look at it this way. Think of the 2 as 2 over 1, and then multiply across the top and bottom. 2 times 1 and 1 times 3. Oops, I let the cat out of the bag, so to speak. This video, we're going to look at a specific kind of question, a specific kind of skill that you're all going to master very soon. We're going to be looking at finding a fraction of a whole number, and where we're going to begin with cases where the denominator of the fraction is a factor of the whole number. Now, it doesn't have to be. If I asked you for 2/3 of 20 or 2/3 of 22, the answer would not come out to be a nice whole number. So we're exploring a certain class of questions, finding a fraction of a whole number where the denominator of the fraction is a factor of 21. 3 is a factor of 21. Or in other words, 21 divided by 3 is a whole number, 7, right? And that's going to be our entry point into multiplication with fractions. And I said I let the cat out of the bag a little bit because the way we multiply fractions is to simply multiply across the top and bottom. There's a great irony in middle school math. That word irony, that's a noun. The adjective form of it is ironic. And ironically, the word irony is hard to define. It's you kind of know it when you see it, but it's kind of hard to define. One way to define irony, it's like something that seems weird, something that seems the opposite of the way it should be. That's not a great definition of irony. You should ask your language arts teacher about that a little further. Irony is a great part sometimes of literature. But the irony in middle school math is that the easiest thing to do, which is to multiply 2 fractions. It's hard to think of something easier to do in middle school math than multiply 2 fractions, because we just multiply across the top and bottom. We do not need a common denominator. So I've just told you how to multiply fractions. It's easy to do, but it's hard to explain why it works. This video is my first attempt at doing that for you with a certain class of multiplication problems. Now you might say, well, why is this multiplication, Mr. LaBeouf? You've got that word of there. Well, our entryway into the multiplication of fractions is going to be through that word of we're going to equate that word of with multiplication. So back to the question of what is 2/3 of 21. First, break the 2/3 down into 2 times 1/3. Okay. I think you're probably comfortable with that, the fact that 2/3 is 2 times 1/3. And then come over here and say of 21. 2 times 1/3 of 21. There's something called the associative property of multiplication, which tells us that we can, if we have 3 numbers being multiplied together, we don't have to go left to right. We can jump to this point, and we can do the 1/3 of 21 first. And what is 1/3 of 21? It's 7. It's 21 divided by 3. This denominator of 3 serves a division function. So this is one reason why fraction multiplication is complex, because there's an aspect of division within it. But we've seen that before. When we're talking about thirds, you know, how do you create the thirds number line? You divide the distance between 0 and 1 into 3 equally sized pieces. So this 1/3 of 21 is telling us to divide the 21 into 3 equally sized pieces. And each piece, of course, would be 7 units long. The answer is 14. 2/3 of 21 is 14, because 1/3 of 21 is 7. And 2/3 of 21 is twice that. 2 times 7 is 14. So there you go. They're all going to work like that. So they're easy, but I'm going to use this easy kind of problem as a gateway into multiplication with fractions, which it's going to be more complex when we move into different types of problems. Let's look at 3 related questions. 1/3 of 21, as I said before, is 7. 2/3 of 21, 14, twice as big. 3/3 of 21 would therefore be 3 times 7, or 21. Wow. 3/3. As soon as you see 3/3, you know now to think what? What is 3/3? It's 1. Here's part of what we're going to do in order to understand the multiplication of fractions. We're going to equate the word of with multiplication. Now, in 3rd grade, it sounds funny. If a 3rd grade teacher were to say to her students or his students, what is 2 of 3? That sounds weird. But if the teacher said, I want to force you to answer, I want to force you, even though it sounds weird, what's your best guess at what it should be? 2 of 3. And I think a lot of students would say 6. How about if I add in the word groups, which we frequently do when we're learning whole number multiplication in 3rd grade? What is 2 groups of 3? Well, now every 3rd grader says 6. So I'm just trying to get you to see that word of is naturally related to multiplication. And so every one of these words of here could be replaced with a times sign. 1/3 times 21 is 7. 2/3 times 21 is 14. 3/3 times 21 is 21. And that's as far as we can go, right? Wrong. There's no limit to how far we can go. You tell me, what is 4/3 of 21? Well, let's just make this observation. 4/3 is greater than 1. You know that. 1 times 21 is 21. 4/3 times 21 has to be greater than 21, because the 4/3 is greater than 1. Back to 1/3 of 21. 1/3 of 21 is 7. 4/3 of 21 is 4 times bigger. So it's 4 times 7, or 28. notice as we go down the list of problems there, the answers are increasing by 7. Why? Because one third of 21 is 7, and we're going up by 1/3 each time, so we're adding another 7 to the result. 5/3 of 21 would be 5 times 7, or 35, right? 5/3 of 21 is 35. 1/3 of 21 is 7. 5/3 of 21 is 5 times bigger than that, so it's 5 times 7, or 35. And this is essentially how they work. Once you get the hang of it, it's very simple. And if I were to put up another, say, 6 problems, I think you'll get them all. All right, take a look at the 6 problems and try to figure them out. Pause the video. I'm going to pause the recording. Pause the video. See how long it takes you to come up with all 6 of the answers. You can use a piece of paper if you want, just to maybe jot a little bit down, but essentially you should be able to do them mentally. Give it a try. This particular class of questions, we're finding a fraction of a whole number, and the denominator is a factor of the whole number. So the answers are all whole numbers. But please understand, if I didn't rig them this way, then the answer would not come out to be a whole number. So in other words, if we had 5/8 of 23, not a whole number. If we had 5/7 of 24, not a whole number. See, these are all whole numbers because the denominator is a factor of the whole number. Now the first one is 5/8 of 24. 1/8 of 24 is 3. It's 24 divided by 8. So 5/8 of 24 is 5 times 3, or 15. I bet you got that. I bet you got them all. 2/7 of 21. 1/7 of 21 is 3. So 2/7 of 21 is 2 times 3, or 6. 9/10 of 60. 1/10 of 60 is 6. 9/10 of 60 is 9 times bigger than 1/10 of 60. So it's 9 times 6, or 54. 2/11 of 55. 1/11 of 55 is 5. So 2/11 of 55 is 2 times 5, or 10. 10/11 of 55. Well, 1/11 of 55 is still 5. So 10/11 of 55 is 10 times 5, or 55. And 51/100ths of 600. Not that hard. A little bit harder than the others. What is 1/100th of 600? 6. So 51/100ths of 600 is 6 times 51. You should be able to do 6 times 51 mentally. 6 times 50 is 300. 6 times 1 is 6. Put them together, 306. Estimation, or the use of number sense, is always an issue in math at many different levels. Sometimes an estimate is a little easier to come up with than others. We'll focus on a couple of these. How about if we look at 9/10 of 60? Well, anytime you take 9/10 of a number, you're taking almost the whole thing. Your result is going to be almost the whole thing. 9/10 of something is close to the whole thing. So your answer has to be fairly close to the 60. And we see that it is with the 54, right? On the other hand, with the 2/11 of 55, 2/11 of something is only a pretty small piece of it. So we were not expecting anything close to 55 with the 2/11 of 55. Whoops, there's a mistake. I hope I said 50 earlier. I wrote 55 here. I'm glad I went through and did this estimation because I just revealed the mistake. 10/11 of 55 is 50 because 1/11 of 55 is 5. So 10/11 is 10 times 5, or 50. Now, the point I was trying to make before I saw that mistake there is this 50 is close to the 55 because 10/11 of something is almost the whole thing. But of course it's less, because 10/11 is less than 1. 51/100ths of 600. Well, what if I had asked you what's 51/100ths of 600? 51/100ths of 600. Now we can go through the process. 50 times 6, 300. Or we can just say, well, that's a half. And half of 600 is 300. So when we saw 51/100ths of 600, we should have been expecting a number a little more than 300. And we got that with 306. If you got them all, great job. If you did not get them all, there'll be opportunities for practice. But this is just an entry point into the question of multiplying with fractions. We're going to, little by little, expand our understanding and our skill set for multiplying with fractions. But as I said earlier in letting the cat out of the bag, bottom line is it's very simple to multiply two fractions, but to understand why it works the way it does is going to require a little bit of storytelling step by step through the process, and that's what I will do with you over the next few weeks. Let's try a few more. I realized that in the last set of 6 problems, all of the fractions were less than 1, and I believe I said earlier that the fractions can be as big as we want. We're not restricted to fractions that are less than 1. So I just want to look at that little issue a little bit more here, and we'll consider certain eighths of 32, beginning with 1/8 of 32. And 1/8 of 32, of course, is 4. It's 32 divided by 8, which is 4. 3/8 of 32 is 3 times more than 1/8 of 32. So it's 3 times 4, or 12. Notice it's less than 16. Why do I say that? 3/8 is less than a half. If I had asked you for 4/8 of 32, right? Just think about that. 4/8 of 32. Well, 1/8 of 32 is 4. 4/8 of 32 would be 4 times 4, or 16. The 16 is half of 32 because 4/8 is 1/2, right? 4/8 simplifies to 1/2. But this is less than 16 because 3/8 is less than half. 7/8 of 32 has got to be something pretty close to 32. 1/8 of 32 is 4. 7/8 of 32 is 7 times 4, or 28, which is pretty close to the 32. And now what about this? 8/8 of 32. Now, for practical reasons, we don't generally encounter something like that. Why? Because it's 1. 8/8 is 1. 8/8 of 32 is 32. Now, we can do it the way we've been doing it. 1/8 of 32 is 4, so 8/8 of 32 is 8 times 4, or 32. Or we can make this observation. 8/8 is 1, you know that, and we are connecting the word of with multiplication. So any one of those words of, I'm not going to actually do it with the marker, but please realize this. All of those words of could be replaced with a times sign. 1/8 times 32 is 4. 3/8 times 32 is 12, and so on. So this is 1 times 32, or 32. Now how about 9/8 of 32? Well, 1/8 of 32 is 4, so 9/8 of 32 is 9 times 4, or 36. Notice it's 4 more. When we went from 8/8 of 32 to 9/8 of 32, we went up by 4. Why is that? Because we went up by 1/8. And 1/8 of 32 is 4, so that's why the answer went up by 4. How about this? 16/8 of 32. Again, you don't generally run into that. Why? Because it's 2 times 32, right? 16/8 is 2. 2 times 32 is 64. You can get to it the same way that we got to the earlier ones. 1/8 of 32 is 4, and 16 times 4 is 64. But the shortcut is 16/8 is 2. 2 times 32 is 64. Easy. These are easy. Back in my early days of teaching middle school math here at St. John's, I used to make a lot of two-dimensional rectangular models of these kinds of questions. That entire rectangle that I just constructed is representing the number 30. And I tried, without measuring, to divide that rectangle into 5 equally sized pieces. And so at this point, what I would say to the students is, what number has to go in each of those pieces? It has to be the same number, and then they all have to add up to 30. Well, of course, it's 6, right? Five sixes make the 30. So then what can we do? On the other side of the rectangle, we can say, all right, I want to consider 3 of those pieces, 3 of those 6s. Well, 3 sixes is 18, of course. And so what this model is showing us is 3/5 of 30. And 3/5 of 30 is 18, because 1/5 of 30 is 6. You can see it right there. That rectangle there, that little rectangle on the bottom, is 1/5 of the 30. It's got 6 in it. If we take 3 of them, it's 18. Very simple. But I said I used to do this a lot in the old days, and I guess I'm still doing it, because there it is. There it is. But then, as time went on, I started to realize that we don't need a 2-dimensional representation of this. It might help. If it helps you, that's fine. You could even construct some yourself. Like, I might say, well, what about, how about 7/8 of 48? Could you construct one of these rectangular models similar to what I just did and show what 7/8 of 48 is? Why don't you try it? You can show it to me after you watch this video. So, hey, Miss LaBeouf, I want to show you my model of 7/8 of 48. Now, 7/8 is close to 1. Taking 7/8 of a number, we should get close to the number. Well, 1/8 of 48 is 6, right? 1/8 of 48, 48 divided by 8 is 6. So 7/8 of 48 is 7 times 6, 42. Well, maybe you just did that along with me without the model, but see if you could make one of these rectangular models. The entire rectangle would be 48, and you'd have to divide the rectangle into how many equally sized pieces? Into 8. And then figure out what goes in each of those 8 boxes, and then take 7 of them. I practically just did it for you. But show me someday. Show me a model, rectangular model for 7/8 of 48 being 42. But as time went on, I started to realize that we can do this on a number line. It doesn't have to be 2-dimensional. And we start our understanding of fractions on the number line by dividing the distance between 0 and 1 into equally sized pieces, right? Now, one of the first things we did in 5th grade was to understand that 5/3 is 1 2/3, because 5/3 on the number line is 2/3 past 1, right? That connection between the improper fractions and the mixed number. And it's all about dividing that unit length between 0 and 1 into equally sized pieces indicated by the denominator. And then the numerator tells you which one you're interested in, which one you count to, right? Speaking of number lines, here's a number line that goes up to 2. And I want to make an 1/8 number line. We're going to look at this problem here, 3/8 of 48 being 16. We just saw the rectangular model of it. It's very easy to do mentally. 1/8 of 48 is 6, so 3/8 of 48 is 3 times 6, or 18. Well, let's make a connection between the number line that we use to learn about fractions to begin with, and then make an adjustment to that number line. See, in teaching math, I'm always trying to relate the new material to what came before, and try to make it a gradual, easy step to the next level. And that can be done from pre-K or kindergarten all the way through high school, through calculus, through college math. Just little steps along the way. All right. I'm going to save time, I'm going to eyeball an eighths number line. It's kind of easy to do because you cut it in half, you cut in half again, you cut in half a third time. So I put a dot about here, a point here. So I've divided the distance between 0 and 1 into 2 pieces, and now I cut each of those in half. So now I've got fourths. It's not going to look perfect, but now I divide each of those again like that, and I've got a decent eighths number line. 1, 2, 3, 4, 5, 6, 7, 8. Right? I could do the same thing between the 1 and the 2. Half, half again, and half again. So this one would be 8 eighths, 9 eighths, 10 eighths, 11 eighths, 12 eighths, 13 eighths, 14 eighths, 15 eighths, and 16 eighths for the 2. It's not a perfect eighths number line, but it'll do. Well, you might be wondering, how are we going to get to 3 eighths of 48 being 18? Easy. Let's just change the 1 to 48. And of course, if the 1 is 48, what's the 2? 96. I knew you were thinking. 96. Okay. It's still the same number line. Notice I've got those same points there, but now we're dividing the distance between 0 and 48 into 8 equally sized pieces. So how big is each piece going to be? If 48 is divided into 8 equally sized pieces, each piece is 6 long, right? 6 units long. 48 is really the new unit. Let's say it this way. Each of the 8 pieces is 6 long, 6 ones long, right? 6, 12, 18, 24, 30, 36, 42, and 48. And we could keep going all the way up to we can keep going as long as we want. All the way to 96, let's go. Adding 4 here, we get 52, 56, 60, 60, oops, oh my goodness. Oh my goodness, we're adding 6, aren't we? 48 and 6 is 54. Then 60 here, and then 66, and then 72, we're adding 6. 1/8 of 48 is 6. 76, 82, 88, and then 96. No. Oh my goodness. $54, 60, 66, 72, 70, did it again, 78. For some reason I wanted to add 4 there. 78, 84, 90, and 96. I can count by 6s. It's late, sorry. Too much turkey. A couple days ago, yeah. That's right, it's Saturday of the Thanksgiving vacation, but I think it's good now. 3/8 of 48. 18. It's right there. That point that we're now calling 18 is in the same, it's the same point that used to be 3/8. See, when that was a 1 here, when that 48 used to be 1, it was 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. But now we just change the 1 to a 48, and that makes all the numbers become these multiples of 6. Okay, so it's sort of an evolution of the fraction number line that we're familiar with, and maybe those rectangular models are better, but this is a little more sophisticated. But I think it works for you. Let's try one more. How about 50 15/8 of 48? Well, 1/8 of 48 is 6, right? Let's do it this way. 15 times 1/8 of 48. Break that 15/8 down. Think of it as 15 times 1/8. And then take the 1/8 of 48, which we know is 6. So now we have 15 times 6. 15 times 6 is 60 plus 30, or 90. Right here. (15/8) of 48 is 90. Okay? Now, this is a connection you can make. When this number line was originally a 1 here instead of the 48 and a 2 here instead of the 96, what was that number? The 1/8 before the 2 was 15/8, right? The 2, when that used to be a 2 before, it was 16/8. And the 8th right before it is 15/8, the same as this 15/8, except instead of 15/8 of 1, it's 15/8 of 48, because we changed the unit, we changed the 1 here to a 48. It's a bit of a subtle point, but I think you can get it. And I think I've done enough for now. We're just over 30 minutes, 31 minutes. I hope you enjoyed this. There'll be a lot more to explore with fraction multiplication, and it will open up a whole new world of many other math problems that we can conquer. Let's do that together. So long. Bye-bye.